In this video, we're going to learn about quadratic functions. So a quadratic function is when you're going to have a term here with the x squared. So ax squared plus bx plus c. Anything that looks like that is going to be a quadratic function. Now, whenever you have a quadratic function, the graph is going to be a parabola, which is the shape that we see right here. Every quadratic function is going to look like this. So you can know ahead of time it's going to look something along those lines, just maybe not in the exact same positions, but it's going to have that same general shape. Now, whenever you have a parabola, there's always going to be one special point in it called the vertex. That's this point right here on the bottom. And the vertex is going to be an important point because it gives either the lowest possible point on the graph or the highest possible point in the graph, depending on if your parabola goes upwards or downwards. Now, we are going to want to find this vertex almost all the time, every problem we have, because it's such an important point on the graph. Well, turns out there's a pretty easy way to do that here, which we can call the Vertex Formula. All we have to do is plug in x is negative b over 2a, and we're going to plug it in to find the y value, so you're going to get a point here. And if you wrote it as a point, the x would be negative b over 2a, and the y is, you get that by plugging in the function, so it'd be f parentheses negative b over 2a, which means you plug in the x number and find the y value. So that point together is going to give you your vertex. So right away you can get there are other ways to find the vertex. One of the main ways that you may have been seen before is something called completing the square. Personally, I am not a big fan of completing the square. There are times when you really want to have it, but for something like finding the vertex, I think it's unnecessary. I think it's better to have the vertex formula to use for that. Now, we also have a second important feature on these graphs, and that is called the axis of symmetry. So the idea is, if you were to draw this little dotted line down the middle here, the graph on either side would be the exact same shape here. It's symmetric about that line. That's why it's called the axis of symmetry. And if you look at the equation for the axis of symmetry, it is x equals negative b over 2a. Now I want to point out something very carefully here. It looks like it's the exact same thing as the vertex formula, but it is not, because in the vertex formula, when I write x equal to negative b over 2a, I'm giving you a specific number for the value of x. Then you would plug it in to find the value of y. So I'm giving you numbers to find a point, and that's what I'm giving you in that case. However, in the axis of symmetry, I am not giving you a single number for x. What I'm doing is I am giving you the equation of a line. So you may or may not remember that if you have a vertical line, it's always x equal to some number, and that's the equation of a whole line, not just a single point. So again, I'm just trying to make sure we clarify that even though it looks like it's the exact same thing here for both the vertex formula and the axis symmetry, they are not in fact the same thing. One is going to be a point and one is going to be a line. Okay, now what are we going to do with these quadratic functions? Well, at this point in time, what we're going to do is we're going to graph them. And the main way we're going to graph them is we're going to find certain important points in the graph, and then we're going to connect them to draw our parabola. And the points you want to find are the following. The first is you want to find the vertex. Now, we conveniently have the vertex formula to help us with this. So we're going to go ahead and plug in what the b's and a's are here. So negative of b, which is negative 4, over 2 times a, that's going to give me 4 over 2, so that means my x value is 2 here. But then I also need my y value, which I get by plugging that into the function. 2 squared minus 4 times 2 minus 5. Well, that's going to be 4 minus 8 minus 5. Now, quick little thing, just to interrupt our calculation here. But when you're tying the vertex here, the second number better always be double and opposite of the first number. So in this case, the first number was 4. The second number was double and opposite, negative 8. That's how you know you correctly have the vertex. If it's not double and opposite, it means you messed up somewhere. Regardless, we'll continue on here. 4 minus 8 is negative 4, minus 5 is negative 9. So that means my vertex is at 2 comma negative 9. Now, once you have your vertex, you're going to want to find your y-intercept. And to do that, we just plug in 0 for x. And we're going to get the point 0, negative 5 here. And the last thing you want to do is you want to try to find the x-intercepts. Now, some of these will not have any x-intercepts, in which case, oh well, you can't do anything with it. But this one does. So we're going to just set it equal to 0 here. And then we factor. And we get two values of x, 5 and negative 1. And so that means my x-intercepts are 5, 0 and negative 1, 0. So I'm going to go ahead and I'm going to count each hash mark as 2 right now. So there's negative 1, 0. And then 5, 0 would be somewhere out here. I did this because of the vertex being 2, negative 9. So 2, 2, negative 9, somewhere around there. And then 0, negative 5 is going to be somewhere around here. And then we know that bottom one's the vertex. So we connect it, and there's our parabola. So again, you want to find your vertex, any y-intercepts, x-intercepts, and then connect them to draw your parabola. That is the way that we're going to be doing these things. Now, once you have that, once you have your parabola, I could also ask you the question, find either the maximum or minimum of this. Well, the max or min is always going to happen down here at the vertex. Vertex is always the max or min. Now in this case, it is definitely the min. It is the lowest point on the graph. And when you want to give a minimum, you can either give it as the whole point, or you can give it as just the y value, and that's how you give a minimum value. So this is how we're dealing with quadratic functions.